Okay, BC Calculus, we're looking at section 3.7, and we're looking in particular with a rate of change worksheet or rates of change worksheet. You can see at the top here, made a big note, we're going to use the graphing calculator wherever we can. So that's going to really shorten your work. This becomes way more conceptual. We're getting into the big ideas. Let's read number one. We're going to do number one together. It says a particle moves along the x-axis. So its velocity at time t is given to us as v of t equals opposite of t plus 1 sine squared of t squared over 2. Part A, they want you to know when your particle changes direction. And so very often kids will think, okay, I'm going to set this equal to 0 and do a number line check. And you can, it's just that, this would be a lot uglier, way less friendly. We're going to go ahead and just get this typed in, just say opposite or negative. Instead of having a t, we're just going to write x. So say opposite of x plus 1. Now sine squared, we're going to have to put parentheses around sine and then square it. So we'll have a sine right in here. Inside we'll have t squared all over 2. So I'll type x squared all over 2. Close my sign, but remember that whole sign expression is squared. So I'm going to close parentheses and hit the squared button. And there we have it. Now, of course, we should check our mode and make sure we're on radians, and we are. And, as you look at this, we're only going between 0 and 3 seconds. So, I think I had last graphed something on Zoom Decimal, and Zoom Decimal is not a bad window to look at in general. You can see it's like 1, 2, 3, 4. It goes a little bit with our window about 4.7, but if x is our time, we're only going to be between 0 and 3. You can see my cursor looking right there. So, and we can always make adjustments, from here as well. If your window needs to be made bigger in the y direction or smaller, we can come to this screen and do that. But let's just graph our velocity curve right here. And you can see here's 1, 2, and here's 3. It sure looks like our velocity curve just visually is negative around here. But I guess it does beg the question, does your curve ever creep over this x-axis, time axis, and might it become positive somewhere around where I'm moving my cursor right here, or even in the very beginning? And, so rather than solve by hand and rather than trying to do a number line check, plugging things in, it's kind of like we're seeing the x-axis as our number line, and you can see we expect our velocity to be negative a lot of the times, but wow, what's happening in those other areas? Hit trace, okay, and I'm going to backtrack, and you can look at these y values. That's your velocity. It's negative. As we keep going, as I keep tracing over here, it's still negative. And, this e negative 4, that's times 10 to the negative 4th. We're getting really small. You can see it's still negative except at 0. And, if you plugged in t equals 0, the sine of 0 is 0. So I don't think there's a big surprise there that velocity is 0 at time equals 0. So we're just going to be real cautious here and see what's happening around, this x value of 2 point something. You can see our y value, our velocity, is still negative, and negative 0.004. As you look at this, you can see it never changed. It never changed there. So, when does velocity change from negative to positive or positive to negative? It never changes direction. V is less than 0 for t between these values. So that's something really, really helpful. It can speed things up so much for you. Let's take a look at part B. It says find the acceleration at time equals 2. You think, well, my gosh, acceleration means I better take a derivative, and I think we can really hit the panic button and say, my gosh, I've got to do a product rule, and I'll also have a chain rule in there, and to be sure you could take a derivative that way and then plug in t equals 2. Let me show you how the calculator can really come to your assistance. If you press on the home screen, I just went second quit, you press math. If you come down to n deriv, you can take a derivative and look at this. You get d over dx. I'm going to say d over dx. Say, what would you like to take the derivative of? Well, do I need to retype all this in here? You could, but there's a much better way to do it. We can hit vars, right by that down arrow. Go to yvars, hit the right arrow. Go to function, go to y1. See, that's why we graphed that first. Right now, I don't have to retype it. I typed it out once, that was enough. And then they'll say, what value do you want me to find the derivative at? And it's at t equals 2. Now, AP rounding, we're always going to go to 3 decimals. 3.713, or if we round, 3.714. You could go either of those, 3.713 or 3.714. Look at this. I just took a derivative I plugged into. You're either truncating or rounding, and you're good to go. We're almost done. Here's part C. A particle is speeding up. By the way, we could say speed is increasing when velocity and acceleration have the same sign. Right? We talked about that in our lesson today. We're slowing down, or you could say speed is decreasing, when V and A have opposite signs. So what are we getting at? Well, I already know that A of 2 is positive. Right? A of 2 is positive. You could think, well, what about V of 2? Well, you could plug a 2 into V, but hey, take a look at this. I could do vars, yvars, function, y1. You're saying, hey, y1, plug in a 2. It's kind of like f of 2 or v of 2 right here. You'd say that's negative 2.480. By the way, you knew already from part A that velocity was negative there. So acceleration and velocity have opposite signs. We could say, is the speed increasing? No. We can say the speed is decreasing. You're slowing down. Justify, that means write a little sentence. Because V of 2 is negative, A of 2, the acceleration, is positive. So guys, that's the type of work that your calculator can assist you with. Like for number 2, you'll have a function here. If you needed to take a derivative, doing it by hand isn't so bad here. You could also do n deriv. But for all future reference, if you needed to ever do a number line check or take a derivative, any of that, let the calculator really help you out. It can be a huge time saver. So good luck. If you struggle on this, or if you had some old questions, don't hesitate to see me for office hours, or just make an appointment and get some help. Okay, best of luck to you guys.